Alright, moving on to section 1.3. This is a one-day lesson also, so make sure you get as much as you can out of it. Otherwise, I can't guarantee that we'll be back to cover this stuff. We've learned an order of operations that exponents, the small numbers, indicate a specific number of times that we are to multiply a base. For example, 5 to the third means we are supposed to take and multiply 5 times 5 times 5, which turns into 125. And 2 to the fifth means we're supposed to multiply 2 5 times, so 1, 2, 3, 4, 5, which gives us the answer of 32. Squares represent numbers that are going to the second power. So a list of the first 5 squares, we would call this, instead of like we called this 5 to the third and 2 to the fifth, anytime you have a power of 2, it pretty much means squared. So 1 squared, of course, is 1 times 1, which is 1. 2 squared, again, is 2 times 2, which is 4. 3 squared, which is 3 times 3, 9. 4 squared is 4 times 4, 16. 5 squared is 5 times 5, which is 25. In your algebra experience, it will help to memorize the first 25 squares. I do have a real brief discussion to help you memorize them. Although most of the work will come from your effort to actually remember them, there are certain patterns that can actually help you remember those. Again, certain numbers are really hard to remember on this list, but 1 through 9 I'm assuming you're okay with. We know 10 squared is 100. Most of you again know 11 squared is 121. 12 squared is 144. That's crucial that you remember that one, because if you look at 21 squared, you notice that 21 squared is the exact opposite direction of 12 squared. For 13, 14, the trick there is that the 2 digits actually are reversed, and you can remember that because 3 squared is 9 and 4 squared is 16, which ends in a 6. 15, I call 25 with a stutter, so it's like somebody saying 25. 16 has to just be memorized. 17, 18, 19, I remember this way. Remembering that 7 squared is 49, which means it ends in a 9, and 7 times 4 is 28. 8 squared is 64, which means it ends in a 4. 8 times 4 is 32. 9 squared is 81, so it ends in a 1. And 9 times 4 is 36. But again, there's certain things you want to do just to try to memorize some of those. Now, however you get them is up to you, but just make sure at some point you try to get used to that, because it helps you, kind of like I tell you with your bell ringers, with the craft of working with numbers. The better you are with working with numbers, the more success you're going to have. Hopefully you've, again, and this is a typical video, but you of course have not memorized the numbers at this point. But what we just learned is that a square is a value resulting from multiplying a number by itself. The opposite of a square is called a square root. So the square root is a number that multiplies by itself to make the value. So when you see this notation here, it means square root of 36, and it means we're looking for the number that multiplies by itself to equal 36, which is why you want to try to memorize that list, because you want to be able to think your way through it. In our experience, we do know that 6 times 6 is 36. And so the square root of 36 has to be 6, because 6 times 6, or 6 squared, is equal to 36. So let's look at some other square roots really quick before moving on to something else. Square root of 100 means think of a number that multiplies to be 100. 7 squared is 49. Nope. 8 times 8 is 64. Nope. 9 times 9 is 81. No. 10 times 10 is 100. That's got to be it. 225. Well, I mean, from what I know on that list that we just had, which is, it's even smart to write. 225 was 15, or 25 with a stutter, which means it's going to be 15, because remember I said 15 times 15 is 225. And square root of 9, again, the number that multiplies by itself to make 9 is 3. And again, that's what square roots are looking for. It's a number that multiplies by itself to equal the particular number underneath the root. Sometimes we're going to be asked to estimate the value of a square root. I showed you some perfect squares, but there are numbers that those are numbers that come out nicely. But again, what if we're asked to estimate the square root of 60? This is our point where your memorization of squares comes into play. Again, we know that 7 squared is 49, and that 8 squared is 64, and that 60 is somewhere in between it. But because 60 is, of course, closer to 64, it's 4 away from 64 and more than 10 away from 49, that is why we can say that it's about 8. If you are asked to know about the square root of 130, again, looking at 130, I know that 11 squared is 121. I know that 12 squared is 144. This is 9 away from that one, 14 away from that one. You can say that it's about 11 because it's going to probably be closer to 11 than 12 because, again, 130 is closer to 121 than it is to 144. A few more. Square root of 23. The number I know is 25, which is your 5 squared. The one before is 4 squared, which is 16. Obviously, 23 is closer to 25, so you could say it's about 5. For 50, the number that comes to mind for me for 50 is 49, which is 7 times 7. 8 times 8 is 64, so the first thing I want to do is pick two numbers that are close. Obviously, it's closer to 49, so you can say the square root of 50 is about 7. For 90, the number that comes to mind for me is 81, which is 9 times 9. 10 times 10 is obviously 100. It's 9 away from that, 10 away from that. That's a pretty close comparison, but since it's only 9 away here, the square root of 90 is probably going to be closer to 9. Alright. So again, that is how you deal with square roots. And the reason you want to do that is because one of the things in this section 1.3a is going to be asking you to do is compare and order numbers. So for this, make sure you have your calculator out and make sure you understand how to program it. We're going to begin by making sure you know how to program your calculator, and it helps if you stay consistent with whatever calculator that you choose. Many teachers recommend getting a graphing calculator, but that's expensive. I like to say that unless you're going to go and get a math degree, you probably want to pick something that is a better purchase. So if you have the money and you're going to learn how to actually use it, which I am going to teach it, go ahead and get one. But the thing is, whenever you go to take a test in the school, they give you whatever calculator. They don't give you any specific calculator, so you don't know what calculator you're going to get if the school is going to give you one, because they don't have that many calculators of one type. My suggestion is that you buy a calculator of a better price range. Texas makes this one, which is the TI-30XS Multi-View. It is a very powerful calculator, and it usually costs less than 20 bucks. Again, don't confuse it with the TI-30, which is what a lot of parents buy whenever they walk out. But you can find it at Best Buy, Walmart, maybe even Myers, and some of the bigger stores, but typically smaller stores don't specialize enough, and so you probably won't find it at the Walmart or at the Walgreens and other things like that. Anyway, I'm going to be using TI calculators through these videos, so you're going to be able to follow along if you're using the same. For now, let's just make sure we understand how to program our basic number translation. So in terms of ordering numbers, sometimes numbers are going to be in a different form, and so if you imagine one person speaks Spanish, one person speaks German, and neither one understands the other one's language, both of them have to find some sort of a common language to be compared or to communicate. And in order for them to communicate, they both have to translate their words into something else they could speak together. For example, English. Numbers work the same way. The common language for all numbers is decimal. That's why you've heard me say I want you to convert your answers into decimal form, because decimal is the form that every number speaks. For example, we've seen that if we want to convert 3/5 to a decimal, we simply type 3 divided by 5. I hope you remember that, and I hope you understand that this is 0.6 on your own. And again, do that in your own calculator to make sure you know how to make that number match. This is where we are learning to make sure we know how to do this. The square root button is usually next to a square because they're opposites. So if you see a squared key or something with the little 2, it's usually going to be pretty close. You might have your own square root button, but in a lot of calculators, the square root button, even on your TI calculators we have, is above the square button. And so in order to get there, that means you have to hit second x squared. Actually, let me change the mode on my calculator real fast. Okay. So hit second x squared, which brings up your little root, and then 75, and of course again it gives you a decimal. We're going to round it just for now to the nearest hundredth, 8.66. Even symbols can be converted to a decimal. Some calculators actually have the pi symbol. Just hit pi, hit equals, round this to 3.14, And E is a weird number. It's actually above the natural log, which is ln, and it's kind of weird to type in. You don't have to worry about this so much pretty soon, but 2.72 is what that rounds to be. So because you can compare everything into a decimal, any two numbers can be compared to make whatever call you need to make in terms of greater than or less than. But before comparing, let's make sure we actually understand what greater than and less than actually are. If you consider the number line integers from negative 10 to 10, negative 10 being here, I don't think I'm going to have enough room, but I think you get the point. What you should know is that whatever number is further to the right is greater. For example, we know that 4 is bigger than 3, we know 3 is bigger than 2, we know 2 is bigger than negative 1. But based off of this chart, negative 1 is bigger than negative 2 because it's closer to 0. Negative 2 is bigger than negative 5 because it's closer to 0 on the negative side. The way you want to view your negatives is that the bigger negative is smaller because negatives are the opposite of positives. In positives, we look for the bigger number to be bigger. In negatives, you want the smaller number to be bigger. Again, think about it like debt. Would you rather owe $2 to somebody or owe $4 to somebody? Typically, bigger is which one is more preferable in terms of that situation there. All right. So using that logic, let's compare some numbers real quick and see that we understand it. First off, negative square root of 2 means I have to do the square root of 2, so I hit second x squared 2. Second x squared 2, which is about 1.41. So this is negative 1.41 compared to negative 1.5. So again, keeping in mind they're both negative, the ones match. And again, thinking that this is negative, would I rather owe $4 or owe $5? Of course I would rather owe $4, so that means that this one is bigger. Again, comparing spot for spot. So ones compared to ones, we have a 1. Tenths compared to tenths, this number is bigger, so we're going to go with that. Square root of 10 and pi. So again, second x squared 10, which is 3.16. We just saw that pi is 3.14. Tie on that one. There's a tie on that one. But 6 is bigger than 4, so we stay with this one. Negative 7/3 compared to negative 2.33. Again, 7/3, I really don't need the negative. 2.33 is what that turns into. I'm sorry, it's 2.333, because what I notice is that this number and my rounding would be the same, so I want to take it 3 digits this time. So this is negative 2.333 about, compared to negative 2.33. Again, comparing. The tie is in the first spot, tie is on the second spot, tie is on the third spot, and there is no fourth spot. And what you can do behind the decimal is add a 0, which is why I gave this to you. This is where we make our decision. In terms of negatives, would you rather owe $3 or would you rather owe $0? Of course, we'd rather owe $0, so this one is actually bigger. Again, because it's negative, 0 is bigger than 3. You have to make sure you pay attention to that logic whenever we work that out. Square root of 1.5 is about 1.22. 6/5 is 1.2. And again, looking at this, first place is a tie, second place is a tie. There is no third location to match, so what we do is we add a 0 and compare it. Because this is positive number, 2 is actually bigger than 0, which means it goes here. Again, over here we were in negatives, and you'd rather owe 0 than 3. And that's the two mind states you have to have whenever you compare numbers. Alright, so you're going to be asked to do that. If you have an issue with that, please come up, ask me the questions you need to ask me so we can go on and get you where you need to be. Before beginning this one, again, be sure you understand how to translate numbers into decimal form. Also, be sure you understand how to think your way through comparing negative numbers. Again, think in terms of debt. Would I rather owe one amount versus another amount? This lesson is very basic, but its simplicity is very important. Most people miss this question because they rush through it and do not feel like doing the work or just do not care. As long as you avoid all the pitfalls, you should get 100% of these problems correct. but this is the question that most students miss, and again, it has nothing to do with their intelligence. It has more to do with their level of patience. The question you're usually asked to do excuse me, is to place values in order from least to greatest. And so the first thing you want to do is make sure every number is in decimal form. That number is in decimal form. 4/5 is not, so I'll do 4 divided by 5, and that turns into 0.8. Negative 1.3 is in decimal form. Square root of 40, again, I don't need to type the negative because I know what I'm looking for. I know the negative's there. As my calculator seems to be acting up. It's 6.32, so negative 6.32. 0.9 squared is 0.81, and the number 0. The first thing you want to do whenever you place values in order from least to greatest is go to your negatives. Here is a negative here, a negative here, and a negative here. And again, in terms of negatives, the biggest negative is the smallest. So start with the biggest negative, and you might even want to write that list. That is the biggest negative to the biggest positive. That is pretty much what's going on. So the biggest negative here is negative 6.32, which means we don't want to use that version. We want to use the original version of the number, which is negative square root of 40. And then I would cross that off the list. The next biggest negative is negative 6, and cross that off the list. The next biggest negative is negative 1.3, and cross that off the list. Now you're on your positives. So remember, it's biggest negative to biggest positive, which means we're looking for our smallest positive number, which is in between them, 0. Crossed. So here you are comparing 0.8 to 0.81, which we know how to do by saying, well, if I add a 0, 0.8 is actually smaller, but again, keep in mind, you don't want to use that version of it. We want to use the original, which is 4/5, and then 0.9 squared. And that's pretty much it. So again, you'll get some practice on that. The key thing again is making sure you have somewhere in your note that when you put them in order, you're going from your biggest negative to your biggest positive. No matter what the numbers are, just follow the system. Separating the negatives from positives keeps us from misleading or misreading the amounts. Organizing and translating our numbers neatly allows us to think clearly and make better decisions. Just keep in mind that we start by arranging the negatives, then 0, then the positives, and everything else should work out, I think is what I meant to type. So go ahead and come and get a worksheet and get your practice. Again, keep in mind we're moving on tomorrow, and so your number one objective is to make sure you understand what's going on. Good luck.